All right, we're moving on to 4b.3, which is multiplying complex numbers. Again, our mission is I can multiply complex numbers. Should be an easy progression, right? We already talked about addition and subtraction, so now it makes sense that we would move on to multiplying complex numbers. And again, I just want to re-emphasize again, we try to do this every time, that complex numbers are really made up of two parts, and we format those as a plus bi. And again, this a here is our real part of the number, whereas our bi here is the imaginary part of the number. So that's what makes it a complex number. And so we're going to be talking about multiplying complex numbers, but like we do almost every time, is I try to bring in some previous knowledge and to try to help you to understand how this relates to everything you've learned before. That's the thing about math is progressive, in that everything that you're learning now is actually just kind of reformatted from something that you've already learned before. So let's kind of look at this and imagine if you had these two binomials, x plus 2 times x minus 4. Well, let's throw that one out there. And again, how would we, if we were asked to simplify this, and we would know that we need to do the old process that we've become very familiar with, which is FOIL, which is basically just the distributive property, right? All I'm doing is I'm taking my first terms and I'm multiplying those, and then I'm taking my outer terms, multiplying those. So I'm really just distributing this x through this term, this binomial, and then I would move to my inner terms and then to my last term. So again, I'm just distributing the 2 through these two things. So we know how to do this already, but we'll walk through it real quick. We're going to get x times x, which is x squared. We're going to get x times negative 4, which is negative 4x. 2 times x, which gives us 2x. And then 2 times negative 4 gives us negative 8. And again, all we would have to do here is x squared. Go ahead and collect these like terms here, which would be negative 2x minus 8. So this would be our finalized answer for that particular one. So again, we kind of already know how to do this process, but let's just think about this now in the terms of multiplying complex numbers. So not very much different. What if I had 4 plus 7i times 1 minus i? Okay, so the same exact type process I've got going on here, but just notice I've kind of flipped them around from where they originally are. You notice I've got something that looks like it's got a variable with it over here. But again, that is an I. That's our special I that we look at. So let's just do the same process. So I'm going to do 4 times 1, which is going to be 4. And then I'm going to do 4 times negative I. Well, 4 times negative I is just negative 4i, okay? Then I'm going to do 7i times 1, which is just going to be 7i. And then here I'm going to get 7i times negative I. So I'm going to get negative 7i squared, okay? And again, just kind of take a look at that. And we'll look at that in detail here in just a second, but it kind of makes sense. It's like this x times x here made an x squared, right? So the same thing's true here. I've got 7i times negative I is going to make negative 7i squared. It's very similar to what we had up here, but there's going to be one little tweak here that we're going to do. And you notice again that my terms that I need to collect, my like terms, are always in the middle. So again, it's working out a lot like what we've already seen before. So I'm going to have 4, and then I've got negative 4i plus 7i. Well, if I had 7i and I took 4i away, then I'm going to be left with 3i. Notice what happens right here. Here's where I really want to look at and spend some time on, because again, we could actually simplify this out just a little bit more. Think about this as being negative 7 times I squared. Well, you remember when we did our little circle that we discovered that I to the first is the square root of negative 1, okay? And we figured out that I squared is actually negative 1, okay? We figured out that I to the third is actually negative I, and then I to the fourth actually is just 1. So notice that I squared is equal to negative 1. So anytime I see I squared, it actually will become negative 1. So really what I have is negative 7 times negative 1, because I squared is equivalent to -1. So really I have -7 times -1, which is just a +7. So notice what really happens with this -7i squared is it ultimately just becomes +7. So whatever you got, whatever number that you have multiplied times I squared, remember anytime you multiply or divide by a -1, it just becomes the opposite. The sign just changes. So notice again, -7i squared is going to be 7. Let's practice one here real quick. What if I had -3i squared? Well, again, I squared is the same thing as -1. -3 times -1 would be +3. What if I had 6i squared? Well, instead of 6 times I squared, I really got 6 times -1. Well, 6 times -1 would be -6. So you notice that whatever number I started with here, it really just becomes the opposite when I multiply it times I squared. So it's a little trick here that we see. So really this -7i squared becomes just a +7. And notice now I've got some more like terms that I can actually add together. Notice that I've got, make this red, notice that I've got a +4 and a +7. So now when I add those two together, 4 plus 7, I'm going to get 11 plus 3i. So you can notice that this whole multiplication process here actually didn't end up with a trinomial like I ended up with here, but in this case, I ended up with a binomial because I had some terms that canceled out. So again, just kind of see this process and how this works, and specifically this part right here, okay, that when I take anything and multiply it times I squared, I'm going to get the opposite of that same number, okay? So this is exactly what you're going to be doing today. You're just going to be folding out these binomials, and again, just coming up with an answer similar to this right here. So hopefully this has been helpful. If you need extra help, make sure to reach out to us, and we'd be glad to help you with that as well. Thanks, guys.